You are given an array prices, where prices of I is the prices of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and then choosing a different day in the future to sell that stock. Return the maximum profit that you can achieve from this transaction. If you cannot achieve any profit, return 0. So by looking up here, we've got this prices array, right? And that prices array has been mapped out here on this graph. And just by looking at this, we can tell pretty quickly that the buy point would be right here and the sell point would be up here. And the reason that is because this is where we would find our maximum profit. It gives us a profit of 4, which is the greatest profit in this array or on this graph, right? But imagine that this spanned out across 1,000 days and it was much harder to eyeball. Well, what algorithm could we write that would solve this problem and return the maximum profit? A great solution we can use is a 2-pointer solution. So we will start off with a left pointer and a right pointer. These will be our 2 pointers. The left pointer will be at the starting index or the first index in our array, and the right pointer will be in the very next index, so the second index in our array. And we will start off with a profit of 0. And the reason we're starting off with this profit is because we want to return the maximum profit, but if no profit can be achieved, then we want to return 0. So we will set profit by default to 0, and then we will begin to iterate through our array. And on each iteration, we want to do 2 checks. We want to check if the right pointer is less than the left pointer, not the index of them or the indices of them, but instead the value. So is the value of the right less than the value of the left? In this case, it is not, so we don't do anything. Then we check, is the right value minus the left value greater than or equal to the profit? And as we can see, the right value is at a value of 4, and the left index is at a value of 2. So 4 minus 2 is 2, and therefore we have a new profit of 2. Now we go ahead and we iterate on to the next element in the array, and we increment the right pointer by 1. So now the right pointer is at the third element in the array, and we do our 2 checks. Is right less than left? Yes, it is. So in that case, what we do is we move the left pointer over to equal the right pointer. And then we don't even check to see if right minus left is greater than profit, because right minus left in this case is, well, it's going to be less than 0, right? And if it's less than 0, we know that we're not getting a profit. And so we don't even want to do the check to see if it's greater than the profit, because it can't be greater than 0 if it's negative. So what we do is we move it from over here. Since right is greater than left, we move our left pointer over here. And then we iterate through. So we do r plus 1. We move r over here, and we check, is right minus left? Well, first off, is right less than left? It is not. Is right minus left greater than 0? Well, right now, right is 2 and left is 1. So 2 minus 1 is 1. 1 is not greater than our current profit, which is 2. So we continue to iterate through. And then we check here, is right less than left? It is not. So then we do our second check. Is right minus left greater than profit? And right minus left is greater than profit, because right is currently at 5, the value of 5, and left is currently at the value of 1. So we then would be removing this 2 with a 4, because the maximum profit so far is 4. And we continue to iterate through our array. And we move r down here. And then we say, is r less than L? And it is. So we move our left pointer down here with it. And this is where it can seem a little bit confusing, because we might think we should be keeping the integrity of our pointers, that they should remain at the indices of where the profit was the best. But we're not worried about that. We don't really care too much about those positions. We just care about the maximum profit. So at this point, we are at the final index of the array. There's not another position to move towards. So we will pop out of our loop and return the profit. So that's how we solve this problem. Now let's look at the space-time complexity of this solution. So for the space complexity, we have 3 different variables that we've created. We have our left pointer, our right pointer, and our profit. And they're all number type values. So they will be holding constant size inside of memory. And therefore, our space complexity is O of 1, a constant complexity. Then our time complexity is going to be O of n. And the reason it's O of n is because we're looping through our input array of prices, and we're going through each element in the array. All right, so now let's jump into the code editor and implement this solution in both JavaScript and Python. Okay, so let's start with our JavaScript solution. The first thing we want to do is create the profit. So we'll say let profit equal 0. We'll set it as default to 0. And then we'll create our left pointer, let left equal 0, and our right pointer, let right equal 1. And we'll open a while loop. So while right is less than prices dot length, because we want to loop through the entire prices array. So we'll iterate at the end here with right plus 1, so right plus plus. And now we want to implement our 2 logical checks. So our first one is if prices at right is less than prices at left. And in this case, we simply want to assign the value of right to left. So left will equal the value of right. And then we have another check. So we'll say else if prices at left, or prices at right, so if prices at right minus prices at left is greater than our current profit, right? So we want to check if prices at right minus prices at left is greater than our current profit, and if it is, then we will set profit equal to this right here. So profit equals this. And that is pretty much all we have to do. So then we will pop out of our while loop here and then return our profit. So let's submit this and bet our lives on it. Amazing. Okay. So that is how we do it in JavaScript. Just to reiterate real quick, we are implementing our 2 logical checks here. We're checking to make sure that right is not less than left, or if right is less than, if our right pointer, the value at our right pointer is less than the value at our left pointer, we want to move that left pointer over to our right pointer's index. And then we would actually increment our right pointer and go back to the while loop. But if this wasn't true, then we would have this else if clause. So else, and then we check if this is true, or if this is true rather. Else, if this is true, then run this code. So we are checking to see if the prices, or if the profit is less than our prices at right versus our prices at left. So the value of this, our right pointer versus the value of our left pointer, if that right value is, when subtracted by that left value, is greater than our profit, we want to change the value of our profit to be this value, prices at right minus prices at left. And then, so either of these that we hit, either of those that we hit, we're going to hit one or the other. Then we will increment our right pointer by 1. And then we finish the while loop and return profit. So that's it for JavaScript. Now let's go into Python and solve it here. So the first thing we'll do is set our pointers and our profit. So profit equals 0, left equals 0, and then our right pointer equals 1. Now let's open up a while loop. So while right is less than the length of our prices array, we want to do our 2 checks, right? So we will check if prices at right is less than prices at left. We want to set left equal to the value of right. So we want to move that left pointer over to our right pointer. And then we would iterate through, right? So we would iterate our right pointer, right plus equals 1. That's the way of saying, right equals right plus 1. We're incrementing it by 1 for each iteration of our while loop. But the second check we want to do is we want to say, like, else if this is not true, then we will check if prices at right minus prices at left, is this equal, or is this greater than profit? And if it is, what we want to do is we want to set profit equal to this value, right? Because if it's greater than profit, we want to change out our current value in profit to this new value, because this new value is greater, meaning that there is a greater profit to be earned in this array. And so in either this will run or this will run, and either way we're going to increment our right by 1 until it is out of the range of the prices index, and we'll pop out of this while loop at that point and return profit. So we return profit. Now let's go ahead and not even run that. Let's just submit it. Let's bet our life on it. Beautiful. Okay, great. So that is how we solve it in Python.